Thank you very much, Betty. And thank you all who are joining remotely. The talk here, as Betty said, will be about API gateways and specifically modern API gateways built on Envoy and some of the challenges that we see when we try to adopt this type of API infrastructure across hybrid deployments or multiple clusters. And the reasons why you might do that, the challenges that you would face, some of the things that Envoy can do to kind of be a building block to solve some of those challenges. And then what we're doing at Solo, we're going to talk about all of those things here today. So again, my name is Christian, Field CTO here at Solo. Been involved in the Envoy community and the service mesh communities for the last 3 years, or actually a little bit longer. And I came to Solo because Solo is focused on helping people adopt and be successful with this application networking technology that includes service mesh, includes gateways, includes management tools, includes some of the things that we're going to talk about today. And I enjoy blogging about this stuff, writing about it. I'm writing the Istio in Action book, written a couple others, and working closely with the Solo customers and watching them succeed in adopting this type of technology. And the challenges that those customers typically have is they're modernizing their application infrastructure. They are going to a microservice style architecture, or rather a decoupled application architecture, for the purposes of going faster and being able to deploy their code, deploy their services faster, independently, scale them, and so forth. And a lot of that just comes down to, what are the processes in place? How is the organization structured to enable that? And what are the complementary technologies that can help with that? And the way we're looking at it is, there's lots of open source technology, innovative technology, containers and Kubernetes and so forth. And that allows you to deploy your applications just fine. But once they've been deployed, there's the issues around those services communicating with each other, around discovering and finding each other, the security requirements that crop up. And especially when you go to cloud infrastructure, which is highly dynamic, ephemeral, and so forth, with smaller services, independent services that are changing rapidly, the need to understand what is happening in the system in real time, so that you can also reduce your mean time to recovery and the number of failure incidents and so forth that you have in your system. So those are the challenges that our customers are facing, and that we are uniquely positioned to help them with. And what does that look like from the Solo perspective is, as you start to modernize your application architecture and go to, let's say, containers or Kubernetes or cloud-based infrastructure, you need a way to tie together the point of arrival architecture that you're working on with what you have existing. And you need something that is well suited to live in that new cloud environment, right? You're investing in technology today for the next 2, 3, 5 years, right? And so doing that on modern technology is really important. So Glue we built as an API gateway to be that stepping stone in that direction, and solve some of the initial challenges around moving to microservices. And we'll talk a little bit about that. Next thing we're doing is, as you get to this distributed architecture, that services, when they communicate with each other, they still need to be secure, observable, and be able to control routing, enforce access policies, and so forth. And so that's where the service mesh fits into place. And at Solo, we have a very strong competency in Envoy Proxy, and that naturally translates to a lot of the service mesh technologies. So we're building management tools and management capabilities to layer on top of a service mesh to do things like upgrades, to do things like failover and automatic and transparent failover and routing, to do things like service discovery, identity federation, all of these things that you need when you run a service mesh in a non-trivial way. But like I said, our core competency is in Envoy, and that translates to the other service meshes. So we're able to advise, and even, for example, with Istio, we're able to support it in production and so forth. So we see service mesh as a big part of this story. And lastly, and just notice the slide transitions weren't in the Assembly Hub, WebAssembly Hub was already showing there. Lastly, the need to customize and do last mile integrations with your existing organization, existing investments, and extend the capabilities of the data plane and maybe even the control plane. So we built a WebAssembly Hub to help automate and take a lot of the boilerplate and the things that are not nice about building and deploying and managing WebAssembly modules to be able to extend things like Glue or Istio and any Envoy-based technology. So that's the way we're looking at it. Helping folks adopt the next gen technology to support their API infrastructure. And we work with some very large household name companies, some of these which are publicly shared, and you can go to solo.io/customers and see the rest of them, and a lot more that are not publicly shared. And we've caught the attention of analysts and investors and reporters and so forth, and won awards and so on. But I guess the point is we are focused here at Solo on helping people go down the realistic path of adopting Envoy, adopting service mesh, and in those cases, it's there are multiple different clusters we're deploying on, different types of infrastructure, different types of policies and compliance and regulations that we have to deal with, and getting that working nicely, that it ends up achieving the customer's goals, is not all that straightforward, and is something that we specialize in. So, coming back to the technology, what are some of the challenges that folks see that might necessitate an ingress or an API gateway? And it basically comes down to, when you're building microservices in cloud environment and you're deploying tens, hundreds of services, maybe more, that the idea of an application and single point of entry sort of melds away, right? And so you still need that structure, those boundaries in your application architecture. Otherwise, things can go crazy, right? And work against you. So some of those challenges you can see here on the right: single point of entry, establishing a boundary. The things that you would like to do at a boundary include authentication, authorization, traffic routing. Part of the reason for the boundary is to decouple what's running inside the boundary from what's running outside that boundary. So this boundary could be a Kubernetes cluster, could be multiple clusters, could be a data center, whatever the boundary is. So you might need things like transformations and extensions, custom authentication, rate limiting, these types of things. And you might want to treat some of these services and the APIs that they expose as first-class reusable company assets. You want to treat these as APIs that you can limit access to, provide self-service, monitor and observe for purposes of monetization, and so forth. So you need a way of cataloging these and documenting these and providing self-service capabilities, sort of down the path of a developer portal. And so that's what we do with Glue. And so Glue is API gateway that is built on top of Envoy, as I mentioned. So we leverage some of the core technology that is both foundational and is proving to become the leader in this space, and build these strong API gateway and edge capabilities on top of it, including the support for WebAssembly. Now, WebAssembly is still evolving in the community upstream, but we've started to build the tooling and infrastructure around it to support it, so that when it's ready, you can hit the ground running and use WebAssembly to extend and customize the behavior of the proxy. And so to facilitate that with our commercial customers, we sell Glue Enterprise, which basically supports Envoy in production, which is no easy feat. I do want to say that Envoy is a building block and is quite complicated and complex. What we've done with Glue is kind of simplified the API and given you a partner in Solo to be able to run it in production, support it if things break, patch things upstream when necessary. And then for, again, the enterprise customers, from a feature perspective, we add things like the developer portal. We invest a lot in the security capabilities. That's very important to enterprises. And we'll talk about some of those challenges, the federation capabilities, managing across multiple clusters and so forth. So Glue itself, again, is an API gateway. It is built on Envoy. We've extended Envoy, basically layered filters on top of Envoy, and also supported it with a control plane to be able to drive the configuration in highly dynamic environments, including things like an external auth service and a rate limiting service, where, for example, the external auth service can support functionality like API keys, like open policy agent, like integration, OAuth, OIDC, and some of these capabilities. And you can even extend it with your own custom code, so that the value in that server, the external auth server, is not just it comes with a lot of out-of-the-box capabilities, but you can write your own Go plugins and load them dynamically into the external auth. So you don't have to go write your own and maintain your own external auth service. You can use what's out of the box and customize it with your the capabilities that you need. And so I won't go too much deeper into the capabilities of Glue, but I do want to point out that it is intended to be highly extensible, as it is today. So there's a few options there, and going into the WebAssembly world, make it a lot easier to extend it. It is multi-platform, so it can run on Kubernetes natively with CRDs, but it's not tied to Kubernetes. You don't have to run it in just Kubernetes. We have people running it outside on VMs and so forth. It can be used as a replacement for simple Ingress controllers, like Nginx Ingress controller, and can even tie into service mesh technologies like Istio, like Linkerd, like App Mesh, and so forth, and provide that integration. Lastly, it's as I mentioned earlier, the processes that spring up around your technology and infrastructure is as important, if not more important, than the infrastructure itself. So we're highly focused on the use cases where developers need more control over the configurations that end up driving that infrastructure. So in this case, in Glue, we have a very decentralized API where service owners can own the configurations around, let's say, routing and path matching and request transformation, header transformation, these types of things. And the more maybe central platform team can own things like the security and maybe rate limiting configs and so forth. So the API is very decentralized for Glue. Now that becomes even more important as you start to run your application and microservices across different deployments, across different clusters, across different zones, different regions, maybe different clouds. You have some on premises and some in a public cloud. And running a large deployment like that, or even where you're not there yet, but you're aiming, like that is on your trajectory to be able to support multiple geographic regions, support stringent compliance requirements and so forth. Managing multiple clusters and getting any kind of consistent view over that is very difficult. And so you run into things like, well, now you have security for the boundary, but now you have, let's say, 4 boundaries. What about the security between the boundaries? You have this idea of, well, if one of those clusters goes down, is the rest of the topology smart enough to be able to react to that and change its routing behavior and change its failover and so forth. So these types of challenges come up when deploying across large heterogeneous footprints. And lastly, the things that we're deploying and that we're trying to manage in different autonomous clusters, we're trying to share pieces of configuration. We're trying to build automation on top of it. This is all done. These services that are running in here, again, some of them are first-class business assets, APIs. And so what you need is a way to treat all of the APIs in a unified way, maybe through a developer portal or something, regardless of where they're deployed. And so you start to go down the path of, well, I'm going to deploy in Kubernetes, maybe some on VMs, maybe some in AWS, and I have these problems now. I need something to help manage that, and that's where the federation comes into play. And specifically now, some of the problems that we're addressing with this federation layer are around security. They are around traffic going from one zone to the other. Is it trusted? Can we provide access control across that traffic? Do the services in one boundary know that if if some of those services start to fail, can they automatically fail over to a different boundary, different cluster? Can we manage, get the best of this decentralization, which allows autonomy and independence and moving fast, making changes, so forth? Can we balance that out with the operational overhead and burden that's placed on trying to manage this type of deployment? And so at Solo, this is the type of stuff that we're working on, and I'll show you exactly what's going on here. But it all comes back to what are the capabilities that we're working with? What are the pieces that, if we put in place, can enable solving these types of problems, especially for that last bullet, right? Because if we just have one centralized gateway and we force everything through that, then we're going to end up with the same challenges we saw organizationally and maybe technologically, but definitely organizationally, that we saw with the previous class of integration technology around enterprise service buses, or even the way that API management tooling had been adopted and implemented in your existing organization, where it's highly centralized, owned by a single team. All the processes run through that team. And so that last bullet is very important. We need to balance out the decentralization of its ownership and enforcement with the fact that to operate it, you need to have some level of centralization. So it turns out Envoy plays a very important role in being able to build the infrastructure and automation to solve this type of problem. Now, Envoy, and I've mentioned it quite a few times here, and at Solo, this is a very important component to the types of application and API infrastructure that we build. But Envoy is special because it is highly dynamic in terms of its configuration. So it's driven by an API. It's not driven by, you don't have to munge up a bunch of flat files and shuffle the files around and bounce the server and hope that it takes and doesn't drop anything and this type of, so it's driven by a dynamic API. And that API, in fact, has taken hold as more of a de facto API across these types of application infrastructure type components, to the extent that that API can be used in application libraries and other technology. So that API is hugely important for Envoy. Envoy is also very extensible. So you can write your own filters. The architecture of the code base itself was built to enable customization, enable contribution, which then fuels the innovation that happens in this space. And Envoy is, as I mentioned earlier, kind of emerged as the leader in this space. And the last part, it's at a neutral foundation. It's not owned by any single one vendor. And the maintainers have been very good about cultivating a good community around Envoy. So this is a foundational piece. Just, I think I tweeted in it. Yeah, you can see there that just like Kubernetes kind of coalesced into the platform container orchestrator that people are going to come around. Same thing is happening with this networking technology with Envoy in the Envoy community. So it's very, very important. And some of the features, those are the capabilities that Envoy supports for specifically playing the backbone of a multi-site, multi-cluster, multi-deployment application architecture are a handful of things. I mean, there's a lot, but I'm only going to cover a couple here. One of them is to be able to dynamically respond to the rest of the environment when things are going wrong or they appear to go wrong. So it's reactive in that sense, that it can make decisions, ideally informed by the context that it has, but it can make decisions about how to route around failures, how to mitigate latencies, and so forth. So let's take a look at some of those. The first capability is request racing. And Envoy can do request racing when services and their upstream calls start to slow down, or they time out, but most importantly, they slow down. Envoy can be triggered to retry at a different host and see, maybe that was a momentary, that upstream is slow or overloaded or whatever, but let's try a different host while that request is in flight and see if we can get a response faster. And maybe start to fail over to other parts, other backup services, and just try to get a response and return it within a reasonable amount of time instead of sitting there hanging or timing out and so forth. Envoy can also dynamically figure out what upstream endpoints to route to. So if things start to become unhealthy, then Envoy can decide on its own, based on the heuristics and the observations that it has based on response times and error rates and so forth, whether or not to start to spill traffic over into different hosts and different services that might be located in potentially different regions or zones. So Envoy can do zone-aware routing. Like I said, the Envoy itself decides in this case. There's a variant of that called locality-aware routing, and this is important. Not just locality-aware routing, but what's happening in this model is the control plane is actually responsible for understanding the rest of the topology, right? It's watching service discovery registries. It's doing things like, it can leverage health checking provided by some of those registries. It can take configuration from the operators and so forth, and then synthesize this down into a set of rules that make the proxies smarter. So, and what I mean by that is the control plane drives the configuration for the proxy, but the proxies don't communicate with each other. The proxies just communicate with the control plane. The control plane has a lot of information about what's happening across the entire fleet. And so in this locality aware routing, the control plane can give Envoy information about where each one of these services that it's trying to communicate is located, when things start to go healthy or start to fail, and then let Envoy decide based on locality where to route the traffic. But it's the control plane giving that information and prioritizing that information for Envoy, which means the control plane is actually very important here in many respects, but specifically because of this. The last thing is we can do failover and priority-based routing regardless of where those workloads run. And maybe they run in completely different clusters, completely different regions. And for those, we might have to change the way we do endpoint discovery or endpoint health checking and so forth. And it's another area where the control plane comes into play to be able to help Envoy become smarter about that. So now we understand a little bit about Envoy being sort of the backbone and providing some fundamental capabilities that we can now layer on and start to adopt those in terms of multi-cluster, in terms of multi-region and multi-site. So we'll start off with the simplest way of deploying Envoy as a gateway at the edge, specifically with Glue, and that is in a single cluster. Right? We deploy Glue as the ingress, and it can provide things like rate limiting and authentication authorizations, OPA, Open Policy Agent integrations, web application firewalling, and so forth. And so if traffic comes in, we can route it, and that's all good. Now, when you deploy to multiple clusters, you have a choice. Do you run a single cluster for your API gateway and centralize it? Or do you run the gateway decentralized in its own clusters? Right? And so that is an approach that we see our customers favoring at times. And in this model, you have traffic going into the different clusters, and the API gateway capabilities, enforcement, all that stuff happening as close to the applications as possible, right? And it can do smart routing and canary releasing and all that stuff. Get the L7 capable proxies, things that understand the applications as close to the applications as possible. So that's one route. Some of the benefits, obviously, highly decentralized, no central points of failure, contention of process sort of forming around that centralization and so forth. But some organizations that we work with find this to be too decentralized, right? And then they still want a point, as you can see in this diagram, actually on the left-hand side, we've sort of left out, well, what is that thing that knows how to route the traffic to those different backend clusters anyway? So you do need something there. And that can be simple. I mean, that could be a simple L4 router, F5 or something like that. And but again, some folks and some organizations decide that what they want is more something like this. They want to do 2 tiers of gateways and enforce as much of the API management stuff out of band as they can, and then forward the last mile to those the gateways running in those clusters. Now, in this model, you have we've seen organizations actually able to get rid of their F5s and some of their complicated networking technology and build a lot of configuration as code for the gateway clusters that we see on the left. And on the right-hand side, those, they still have an API gateway in those clusters, but mostly for the traffic that, for legacy reasons or for other reasons, is not going through that centralized gateway yet, or it might not be able to. right? And so we still have the gateway, API gateway capabilities within each cluster. We've also seen where this turns into we need multi-tenancy in the more centralized edge gateway layer. And so we're able to run multiple Envoy proxies and segregate them and isolate their tenancies. So now once we start to go down this path, and you get a lot of the traffic going in through that edge gateway tier, you might get to the point where you realize, well, it's actually some of these do have service mesh in them. They may or may not have service mesh in them, but you might even want to replace the Ingress at the leaf node clusters with simpler Ingress technology as needed, right? And so in this model, you have the edge layer that's still handling API gateway capabilities and forwarding traffic to the leaf clusters, and those may have API gateway installations as well, or they may be more simple Ingress solution. In this case, we're showing the Istio Ingress gateway as one of those options. So now operating something like this becomes difficult. Managing the configs, knowing that, so for example, the configs on the edge tier, if something changes on the leaf, that second tier, the leaf nodes, the leaf clusters, that we need to write automation. We have to figure out how to update that edge tier and vice versa, right? Because there are things like you could add new services to a particular cluster. You could add new clusters in the leaf tier, and routing and the behavior and all that stuff you will need to adjust, and it needs to be dynamic. Now, so in general, operating, securing these connections, so forth, operating this across multi-clusters, that's where we built something called GlueFed. And so GlueFed is a federation management plane that basically knows about each one of these clusters and understands what proxy is running in there, what services are running in there, what is the configuration for that proxy, and can do things like configuration management. So if we want to treat, let's say, two of these clusters as identical from the federation plane, the GlueFed federation plane here, what we can do is specify that config needs to be pushed and treated identically across those clusters. We can do things like, say, for cluster 1, which has service A, and cluster 2 that has service A, that if traffic is destined to any one of those clusters and service A is not available there, then failover automatically to the location of service A, the cluster where service A is running. So we can do a lot of things around automatic failover, and we can do things around locality-based routing. We can even do things around traffic splitting and traffic routing in a more controlled way through having this understanding of the environment, what's running in those environments, and how to configure them. So that's basically, so even in these models, we have multi-tenancy in a edge layer, you have multiple clusters in that edge layer, and so forth. You end up running multiple gateways. The federation management plane can be used to kind of give some central view of what is happening, what are the policies that we want enforced across these different installations, and basically talks directly to the control planes that are running on each one of those clusters. So it's not a control plane to rule them all. It's a federation of the individual control planes. And this is an important point, because as you start to build larger estates of these services, you want to take advantage of the decentralization, right? You don't want single points of failure. And so in this model, we're heavily leveraging the autonomy of each individual deployment or each individual cluster for both, change management purposes, for compliance, purposes, for availability purposes, and so forth. But we're using the management plane to directly talk with those different control planes. If the management plane goes down, those are still individually operated autonomous deployments, right? And so that continues to go, continues to operate. There's no downtime in any one of those clusters. If one of those clusters goes down, that doesn't affect any of the other ones. So there's a very important point to make there. So let me show you an example of what this looks like. Let's go here. We're going to do this across 2 different clusters. And we have Glue installed, let's see, in cluster 1. I'm just running this unkind on my local machine here. So we have Glue installed on cluster 1 and on cluster 2. And if you're not familiar with Glue, let's just take a quick second. We go into the Glue namespace. This is K9's sort of a UI for Kubernetes. Come in here, we see we have the control plane components, and we have Gateway Proxy. Gateway Proxy is the Envoy component. If I do Prox here, we can see Envoy is actually running in the Gateway Proxy. Gateway Proxy is talking to the rest of the control plane as we, the control plane here, basically. Some other supporting components for automatic service discovery and validation and so forth. So we have 2 different clusters, 2 different gateways deployed. We also have a service deployed on both clusters. Echo v1 deployed on cluster 1 and Echo v1 deployed on cluster 2. Now, what we're going to do is we're going to federate these and bring these clusters and these gateways under the management of a single federation management plane. So to do that, we're going to install the federation servers, and we'll take a look at that. Let's actually check to make sure that everything got deployed. Looks like it did get deployed. If we come back here to namespaces, we see the GlueFed namespace now. And we have the GlueFed controller and the GlueFed console. Let's go ahead and, it's this, 8090. We'll take a look at that. If we do come over here at 8090, give it a second, we do see that we have our GlueFed UI. We don't have anything registered with GlueFed yet. So let's continue. So let's register our 2 clusters, cluster 1 and cluster 2, both with the Echo service for this demo. Give that a second. We got the first cluster registered, and we get the second cluster. Now if we come over here, we should see we do have our different clusters that have been discovered, and we see that the Glue API gateway has been discovered on those clusters as well. And we can see the different health states for those different clusters. So let's take a look at the first capability that we can do with the federation, which is federating the configuration. So in Glue, we use a resource called a virtual service to define our routing rules, define our routing table, our security, all kinds of stuff about how traffic should be managed when it comes into Glue. In GlueFed, we're going to use a federated virtual service. And in this federated virtual service, we're basically taking the config and asking GlueFed to place this on the different clusters that require this configuration. And so GlueFed, all of so Glue itself, everything that we do here at Solo follows a very declarative driven configuration model. So what we're going to do is we're going to apply this resource to GlueFed, and then GlueFed will go make that happen. The declarative config says, I want things in this state. GlueFed's going to go do that. What it's going to do is actually go push these configurations to the individual API gateway installations. Again, it's pushing the config to those installations. They have their own control planes. Those control planes get the configuration the same way they would get the configuration if an individual was operating it, and then applies those configurations to its installation. So now if we do a get fed virtual service, we can see in our status field that it was correctly placed. We can also get our virtual services from the Glue running in cluster 1, and we see that is in good state. If we come back here, click on virtual services, we can see that this virtual service has been federated to the remote and the local, both Kubernetes clusters here. Now, if we call the gateway on cluster 1, we see a hello from cluster 1. If we call it on cluster 2, we see that it is from cluster 2, because that routing config that we set up. Now, if we take down the echo service in cluster 1 and we try to call it, we're going to get an error. All right, so traffic is going to cluster 1, gets to the gateway says this traffic needs to go to the echo service. Oh, but the echo service doesn't exist. Return an error. All right, so that's what happens in a normal situation. What we want to do is make those gateways, although they're independent, although they're autonomous, the Federation management plane knows about, hey, there's two echo services running, there's two different gateways. Why don't I give some hints or some config to both of the gateways so that they know that if the echo service in their cluster is down, then just automatically fail over to the gateway, to the other cluster. So to do that, we're going to specify a failover scheme. So from cluster 1, fail over to cluster 2 if the echo service is not available there. So if we apply that, and now we'll actually poke around at some of the underlying configs so you can see exactly what happened. Again, GlueFed is building the configs and pushing them out to the individual Glue installations and their own control planes. Highly, they're not Glue management plane. GlueFed is not directly configuring the Envoy proxies. Right, so it's creating the config based on the context and the awareness that it has of the rest of the environment, and giving that to the different control planes for each of the proxies. We see that this has been accepted, so that's good. If we look under the covers, what it actually configured was, so this is the virtual service that we saw earlier, routes to echo service, but it also configured the way Glue talks to the echo service. And we can see specifically here, there's a part of the config here that specifies failovers. And what is it doing? It's saying fail over, if you can't talk to the echo service running in cluster 1, fail over to the echo service in cluster 2. But you can't talk directly to the echo service in cluster 2. So route it to the gateway. Route it to the Glue gateway that ends up fronting and providing edge access to the echo service running in cluster 2. And how does it know that IP and all of that port and everything? Because the management plane already knows that. So it automatically configured for this purpose. So let's put back echo service on cluster 1. We'll do a sanity check here. So if we call it, it should work. Calling the gateway on cluster 1, we get the response from the echo service on cluster 1. Great, we expect that, right? If we take that service down and we still call the gateway running on cluster 1, that gateway now is smart enough to know that in failure scenarios, fail over to the gateway in cluster 2. So now if we call it, see, we're calling the gateway in cluster 1, we're getting the response from the service running in cluster 2. And what's happening here is goes to the gateway. The gateway knows, hey, I don't have any healthy endpoints for this local cluster. So, but I do have a failover config. So create a mutual TLS connection to the gateway in cluster 2 and forward the request. And now the gateway gets it on cluster 2 and sends it to the echo service running in cluster 2. Right, so we have automatic and transparent failover based on the capabilities provided by the management plane here. So coming back to our slides, you know, Glue is a powerful API gateway. We know operating and running Envoy at scale, whether that's a service mesh or at the edge. So that is our core competency at Solo. And we've built tooling to allow enterprises to become successful at doing this, solving the real problems that enterprises have. So I highly recommend that you come check out Glue. Glue is open source. The GlueFed stuff that I showed is part of the enterprise product. And the rest of the journey, we're here to support you on with support for Istio, support for multi-cluster management tools for service mesh, similar to what I showed here for Edge Gateway. And of course, the next innovative stuff that's happening in this ecosystem around WebAssembly with WebAssembly Hub. So with that, I want to thank you for joining. Invite Betty back in to close us out and see whether there were any questions. I'm happy to take questions about the topic that I presented here or anything that we're doing here at Solo.
Good thing, because the first question here is related to WebAssembly.
Okay.
So Mike was asking, you know, if there is a ballpark estimate on when or if, you know, WebAssembly is production ready. So I think, you know, we've talked a lot about it and there's a lot of excitement around the potential for WebAssembly, but if you could give a little background on, you know, kind of where it is today and its status within the Envoy project and what that means for downstream solutions.
Yeah, definitely. So let's talk about that. So WebAssembly and the stuff that we've been doing here at Solo around WebAssembly, right? Because we announced WebAssembly Hub back in December last year. And then we announced a major revision with the Istio 1.5 release in, I believe that was March. And so basically what's happening is the APIs are still, and ABIs, so the binary interfaces between WASM and Envoy, are still being finalized, and they're evolving, which is good, right? Because people are actually trying to use it and giving feedback and so forth. And so those are still being finalized upstream. So there's basically a fork of Envoy upstream called, I think it's just Envoy WASM, in the Envoy repository where that work is happening. Now, the question about whether it's production ready and so forth is a good one, because it is actually getting bake time, believe it or not. Because Envoy in Istio, so Istio actually builds its proxy off of that Envoy WASM fork. And so the Envoy in the Istio project actually has WASM enabled in it and is using WASM for some of the telemetry extensions that Istio has built. So there's the stuff is moving upstream. If you're running Istio, and a lot of people are running Istio and running it in production, you know, those APIs and that engine is being exercised, and it's going in the right direction. Now, time frame wise, I honestly was hoping that it would be in there this month in August, but it looks like that's being pushed out a little bit more. So I would say my guess is within the next few months, hopefully by the end of the year. So we don't have a definitive time for that yet. But in the meantime, it is still worth checking out and contributing and giving feedback to us about the experience of using things like the WebAssembly Hub tooling, which allows you to bootstrap WebAssembly projects and push them to the repo. So if we come actually look at WebAssembly.
Yeah, and actually the hub and especially the WASMI, which is the CLI experience for this is it's current up to Istio 1.6, just for folks here, so you know.
Yeah, there's definitely a lot of good material on doing that, and you know that developer experience around doing that. But if you click on Explore, you can see that people are kicking the tires on it. The add header one is probably just the that simple demo one. People working on, extracting JOTs from the requests, and I don't know, there's a whole bunch of, adding metrics and trying in different scenarios. So I would say go check it out. It is moving along a little slower than we expected, but it is moving along, and hopefully we'll get that in, because we see that as a very important part of adopting this type of technology.
And you make a good point about by the time it does go, by the time it is merged upstream, since it's already had time in the Istio project for people to play with it, that it's not going to be something that's like, it's brand new. It's already been in use. There's probably lots of people already experimenting with it already. So that's fantastic. Next question here is from Alan. When you showed failover for failed services, the question is, can Federation also be used for a failover scenario due to a non-deployment? So only failover to cluster 2 if the service is not deployed to cluster 1, regardless of the health of that service.
So in other words, a request comes in for a particular service and it just happens to not be there at that.
In this sense, it's like it was supposed to be deployed to cluster 1, but it's like it never happened.
Yeah. So right now, if you saw in the demo, we specified exactly what the primary and secondary services would be. In the next iteration of GlueFed, we're going to leverage the locality information a little bit more, and so that would allow us to route to endpoints that may not exist in that cluster, but locality-wise, they're in the same zone, or maybe they're in the same region, and route that way. So that is definitely down, on the roadmap, on the near-term roadmap.
Alan added a clarifying point. He said, to clarify, I don't want it to go to cluster 2 if it is deployed in cluster 1, but unhealthy.
That's right.
Yeah.
That's right. Okay. Yeah. So basically, we want to leverage locality a little bit more. So if a request goes to cluster 1 and the service lives in cluster 1, then route it there. If the request goes to cluster 1 and that service doesn't live there, but happens to live in the same zone, availability zone on cluster 2, then route the request there, and so forth, right? If it's in a different zone, different region, and so on. So that is exactly, I think, what he's asking.
And what we'll do is after the next version of Federation is out, we'll host another online event like this so that we can actually demo those scenarios out for folks. Yeah. And so for our last question that I see right now is GlueFed part of Glue Enterprise? Yes.
Yes.
And if you would, and where do you recommend running Glue Federation? Should it be in a standalone VM, another cluster? Can you deploy it onto one of the existing Glue clusters? What's the recommendation?
The recommendation is to run it separately. So in this diagram, I don't have it depicted in its own cluster, but it should be in its own Kubernetes cluster. Now, in this demo, the way I ran it was co-located with one of the other clusters. And so that is an option, but it's not the most desired deployment, mostly for failure tolerations. So I would recommend running the management plane separately from the rest of the clusters as appropriate.
Yeah, I guess, and just in case one of the other clusters go down, you don't want it to take down the Federation control plane.
That's right. Yep.
And do we have any? Well, I guess one thing might be potentially sizing recommendations for that Fed control plane.
So typically in the sizing discussions, we're more interested in sizing around what are the capabilities of the proxy, because that ends up taking a lot of cycles, for example, CPU cycles. And when it comes to the management plane, the sizing, the variable that we're most interested in is the number of clusters and the amount of configuration that you have. So the management plane will, although all of the config and all that stuff is stored in CRDs on Kubernetes, it is doing a lot of calculations about the config, what should it be, what should go where. And so the management plane will likely be a little bit more memory intense than, let's say, the data planes that you would see in the actual clusters. So the variables there are going to be, like I said, the number of clusters, how many configurations are deployed in each one of the leaf nodes, and yeah, those will be the big things.
Great. And then last question here is, does Glue Federation assist with Istio service to Istio service federation, specifically for cases where communication between services is not explicitly configured to egress from the cluster?
That is a good question. And I want to leave a little teaser, because as we continue to build out the capabilities of Service Mesh Hub, especially around scenarios where trust domains between the clusters are not the same, maybe identity, the identity model between clusters is not the same. So between Service Mesh clusters and the traffic and the traversal of the traffic between them, let me save that as a teaser for one of the next webinars that we do.
Great. And with that, we are at time. Thank you everyone for joining and for all your questions. We will get this, the recording up and the slides posted to Speaker Deck and out to everyone via email by tomorrow. And we will see you at the next one. Our next talk is, we've got some live streams next week, but then the next webinar is September 10th. So see you online. Thank you.
Thank you.